Welcome back, and we're moving on into the next section of hydrology. Again, I want to point out, and this time I have my mouse active so you can see it. This section right here, think of this as a mountain. Near the top of the mountain, where you have your glacial melt, your snow runoff, your high altitude spring rains, and so on. And then as it moves down, the gradient levels out, the waters become slower, more sluggish, and then move eventually into the flatlands or oceans, depending upon the waterway's final destination. You'll notice the higher the mountain range, the higher the altitude, the lower the temperature. Because the water is moving faster, only heavy material is being deposited, and the area is very rich in oxygen. As the water slows, your gravels drop out, the water temperature starts warming, and as such there's not as much water action, so the oxygen becomes rich. Then as you move into the latter part, it becomes sufficient, and then into the sandy, silt, and mud sections, sufficient at the surface, bottom frequently insufficient. This is the predominant fish species found in these regions. However, you may find fish from this area, such as suckers, chubs, or whatever, may move into these areas temporarily into both waterways, back and forth. They're not locked into this area. They will migrate, but they will generally stay in this area that is preferred by them. So that is the predominant species found in these areas. So we have the regions. We have the trout region. The trout region is immediately downstream from the initial source of the water. Glacial melt, snow melt, high altitude rains, that kind of thing. As the name implies, the primary fish species of this region is trout. The water is relatively cold, rich in oxygen, fast moving, and well suited for brook and brown trout. As mountain streams flow quickly, they are usually rich in oxygen but low in vegetation. Plants can't get a grip on stuff, they get washed away. While the flatland streams move slower and as such are lower in oxygen but higher in vegetation on down into these areas. Chub and some species of cyprinids may also be found in the lower, warmer trout regions. We're talking down in this area, like the sucker, for instance. The grayling region lies further downstream from the initial source of the water. The water is still flowing, so it's still cool and rich in oxygen. The tributary streams of the rivers Danube, Lech, Ishar, and Inn, for example, belong to this category. Not the rivers, the tributary streams. Although the grayling is the prominent species, one can also find some trout, rudd, chub, barbel, sucker, and pike in these areas. River char usually only move into this portion of the waterway in order to spawn. So if you start catching river char into this area, you need to really check it and make sure that it's not into spawning, and or check your charts and make sure that you may have caught them in a closed season. In either case, they need to be released. The barbel region. The barbel species is the prevailing fish in this region, which is immediately below the area occupied by the grayling species. They share this habitat with rudd, nose carp, eel, perch, pike, and pike perch. In the barbel region, the water tends to become a more sluggish river system with slightly higher water temperatures and a reduced oxygen content. The banks are often as well covered with or by heavy vegetation. Now we're moving into the actual river systems or wider, slower moving waterways. The Bream region is the final water division line for many German rivers. The river becomes deeper, wider, and slower with the lower gradient level. The river will also form many pond-like habitats rich with vegetation along its banks. This region is considered very productive. Bream being the main fish species found here, along with other fish species such as roach, rudd, pike, pike perch, carp, eel, tench, and sheepfish as well can be found living here. Trout and grayling are not naturally found here due to the higher water temperatures and lower oxygen content. Trout and grayling are not naturally found here due to the higher water temperatures and lower oxygen content. Brackish water region. Estuary rivers, rivers that empty into the sea, have a brackish water zone. This extends from the bream region to the mouth of the waterway or river. This region can change depending upon the tides. As such, when the tide turns or rises, this will often force salty seawater into the freshwater river and mixes the two, forming a brackish water or water with a lower salt or saline content than the original seawater. Many freshwater organisms that are unable to adapt to this change are killed and become valuable food items for the brackish water dwelling species. The rough, calabash, a small member of the perch family, smelt, and eel are the most numerous inhabitants here. Bream, roach, and at times even flounder can also be found in this region. Standing waters. Standing waters are characterized by a lack of current and by a productivity of a constant stock of fish species that can adapt to this water composition. Lakes, ponds, and impounds fall into this category since standing waters may either be natural or man-made. Factors such as depth, water composition, temperature, types of bottom fauna, plants, and food production rates will determine the fish stocks and classification of such areas. Lakes. There are two general types of lakes found in Germany, with several variations in between. Development and circulation of nutritious matter also determines lake type. Lakes poor in nutritious matter are deep, usually with rocky shores. They are also often blue and transparent with stony or sandy bottoms. Typical representatives of this category would be the Bavarian alpine lakes, which are usually more than 100 foot deep, with some descending as much as 600 feet. Animals and plants produced in these lakes are usually decomposed completely by bacteria during the year. Although these lakes have adequate oxygen in the depths during the summer heat, they are poor in nutritious matter and not very productive. The primary fish species inhabiting these waters are lake trout, lake whitefish, lake char, brook trout, and mountain whitefish, with most of these fish living in the free or open water zones. Standing waters. Lakes rich in nutritious matter, weedy lakes, are relatively shallow and characterized by a mucky, muddy, or silty bottom with plenty of aquatic vegetation. Most flatland lakes belong to this category and are usually no deeper than 60 feet. The abundance of aquatic vegetation provides a large food supply and adequate shelter, making these waters far more productive than deeper, clearer ones. Some of the shallow lakes produce water plants and aquatic animals far beyond their carrying capacity in the summer months, thus increasing the decomposition process later on. Decomposition then depletes the oxygen supply, resulting in a stagnation and loss of fish populations. Fish species that thrive best in these waters are bream, tench, eel, pike, and perch, which will usually inhabit the shore bank lines and bottom areas. Lake zones. A lake basin may be divided into distinct natural zones. The littoral zone includes lake areas where water plants grow or where light is able to penetrate to the bottom. This zone is usually a belt around the shore, but may also include shoal areas out in the lake's main body of water. Think of it as like little low islands, some never really reaching above the water surface. In shallow lakes, this zone may encompass the entire body of water. The turbid zone or deep lake is a body of water where in one or more areas it has an abrupt shoreline drop off where light is unable to penetrate the bottom. This light is needed for plant growth and usually has a limited littoral zone. This extends to the more open lakeward area known as the limnetic zone, which extends to a depth where small floating plants may flourish, but not much more below them. This area is also called or known as the trophogenic or food production zone. This can also include the lake bottom where food is usually consumed faster than it can be produced. Fish and other organisms that live in the trophogenic zone must rely upon food sources that settle down from the waters above them. Each species of organism and fish requires a distinct water composition, average water temperature, environmental conditions, and of course food supply. As such, these lake divisions can also be identified by the fish species that inhabits them. Examples include brown trout, lake trout, roach, bream, pike, pike perch, carp, and perch lakes. More details on this would be covered in the course materials if you take the class. We'll end this here and then move into ichthyology.